So the consequence of allowing polymorphic parameters for your commands or queries is you're going to result in a polymorphic collection of objects. Let's see how this can be exemplified. So let's say we now want to answer the original question we have for our student management system problem. So we say, how can we define a class that contains a list of resident and non-resident student at the runtime? So the answer is you want to have polymorphic parameters so that you can allow polymorphic argument values. Let's say we have a student management system class, and then we have students, linked list or array, doesn't matter, linked list of students. So statically, every member in the linked list is of type students. And then let's say we choose the parameter that's simply of type that's at the top of the student hierarchy over there. So it would simply say student. So that means when you pass the argument values, the static type for the arguments can either be students or resident students or non-resident students. If you're not too sure about this, please refer to the previous video. Okay, and we'll simply add a student to the end of the linked list. And now let's say we have one command is going to register all the students with a common course by using a cross loop. So across all the student S, so S is a cursor to the every member in the for the students, and then we simply say S the item of type students. And then is the register command available on the student class? Yes. You can look up the definition. That one's simply going to add the register course to the end of the student's courses array or linked list. Okay, so now let's see exactly how this is going to occur. Okay, I'm just going to go over this particular little test to show you why the collection that's going to be resulted from this code over here will be polymorphic. Let's go on with the illustration over here. Okay, let's go line by line over here. And now, of course, you got to pay attention to the details about add students, its parameter type, and also for what we call register. It's going to call the register from the student class. Okay, let's go line by line quickly. So we got variables over here already. So we got RS, NRS, we got C, we also got SMS. I can look up their static types. So let's say, first of all, we start with the first objects. Let me use blue over here. So what we want to do for the first one is we want to create the resident students objects, and then we want to set its premium rates. Okay, so what I will do is I'm going to RS will be resident students. You can see there's no curly brackets over here. That means that the dynamic type will just be the same as its static type. So RS is going to point to this particular resident students objects, and the name would just be gym. And the courses initially would just be empty. Okay, initially. And then set a premium rate to be 1.5. So that's the first one. What about the second one? Let's say we want to create another NRS non-resident students object, Jeremy, and also set its discount rate to be 0.5. Let's do it. So NRS is going to store the address of this object here, and the name will be Jeremy, right? So Jeremy. And then the discount rate will be 0.5. And similarly to before, so the courses will just be initially empty, not void, just initially empty. And then we're going to create this SMS, student management system objects, and then SMS is pointing to this object here. And then initially SS would just be empty, linked list. And now it's important to see these two lines. We want to say, first of all, SMS.addS. Okay, we're calling the addS over here and then with RS. Let me just remind you very quickly. So now how do we judge whether this should compile or not? So we're calling addS as student, basically. I'm just using the short form in the code. So we are really referring to the same command. So now implicitly there is call by value. The parameter S over here is assigned to the RS over here. So now should this compile? That's something you should be able to judge. That should compile. But for the reason, you can refer to the previous video. So this is going to work. Okay. Add RS is going to add RS over here to the end of the end of the linked list for the SMS. So what's the consequence of this? So the consequence of this, you can think about this is number one, let's say. So what that will do is it's going to grow the size of the array over here, and now it is going to point to wherever RS is pointing to. Okay, so you can think about, let's say this is position 1. Okay. And what about the next one? The next one, we are calling the same command over here, but now we are with the MRS. And again, implicitly, what you want to think about is whether the parameter s called by value, also implicitly is assigned to NRS. Should I compile? Okay, something I will let you judge. And then for the second one over here, it will compile. And then, so what's going to happen is we're going to grow the size of the linked list over here. So it's going to be 2. And then it's going to point to wherever NRS is pointing to. Okay, so far what we have resulted in is actually a polymorphic collection over here. So you can think about over here, this collection over here is so-called polymorphic. Let me write it down. So this is a polymorphic collection. Because statically every member in the linked list will just be students statically. However, dynamically you can see over here the first member is referring to some objects of type resident students, and the second one is referring to an object of type non-resident student. You can see the dynamic type is different, meaning that when we call some commands or query on that, they might have different behavior because of dynamic binding. We'll see that. Okay, let's continue with the coding here. So let's say the next one we want to do is we want to say create some course over here. Let's say 3311. So what we'll do is it's going to, let's say title is 3311, and then let's say 500. Okay, and then we're going to call this particular command over here. We're going to say register all. So that's going to call the register all command over here to register the course. That one there is not tricky. You simply just go over all the students. In this case, we're going to iterate 1 and 2 iterations. For each one of them, we're going to call register. This one is not very tricky because there's only one version of the register command. Only from the student class, you got a register command from, if you recall the example, right? So this one here is very easy. You'll simply grow the size of the first students over here. In the first iteration, you're going to look at this particular student, right? So that one there, you're going to grow its size of the linked list, and then that one there is going to point to the course. And then for the second iteration, you're going to grow the size of the second students, right? And then that one there, also index 1, is going to point to this particular course. So this part here is not tricky. So now I want you to pay attention to the next lines. SMS SS1 dot tuition, SMS SS2 dot tuition. What we're doing is we're really calling the same query over here, tuition versus tuition. However, the context object is the first element in the list versus the second element in the list, right? You can see first element in the list versus second element in the list. So why would they give me two different answers? So this has to do with the polymorphic nature of the collection. Because dynamically, if you try to see, let me just give you some example here. So let's say I want to do the instance of check for the first element in the linked list for the student management system array. So I can say over here, attached. Remember the syntax we did for the typecasting. I can say attached. And then I want to see if the first element is actually a resident student. I can say rs over here. And then I'm referring to sms.ss at position 1. sms.ss at position 1. Okay, I want to see if that can be cast into, for example, s. For example, it can be just maybe some rs 1, for example, student number 1. So now this would be, this whole expression over here can be placed under check or if, as we explained before. So now this one here is going to be true. Right? Hopefully you can see that, right? Because dynamically, resident students over here can really fulfill the expectation for resident students. So that's a successful cast, and also the check. Okay, what if I put something here? What if I try to put, rather than rs over here, if I simply put, for example, nrs, if I put it there, am I going to get true or false, right? Remember, I'm only doing attach check, so the whole thing is going to be a Boolean expression. So now if I do that, it's going to be false, because dynamically resident students cannot fulfill the expectation for NRS, because NRS is expecting discount rate, which resident student doesn't have. Okay, one more example for you. what if I put, for example, rather than NRS or RS, if I put simply students? So now, would it be true or false? Well, the answer would be, can resident students fulfill the expectation on student? Yes, it can. It's a descending clause of that, so that would be true. So we should really consider these 3 examples that we talked about already, right? Okay, let's finish the example. So now when we do over here SMS.ss1, dynamically it's really pointing to the first object over here. That's the first object that we're pointing to, right? So in that case, we're going to make sure we call the corresponding version because of that dynamic binding. So that one there, the version 2, remember we got version 2, we got version 1, we got version 3 from the previous part. So now we're going to call version 2 of the lecture, version 2 of the tuition. And that one there is going to apply the premium rates, which is 1.5. In that case, we're going to get 750, right? It's quite obvious. And then similarly, so let's say we talk about this one over here and this one here. Dynamically, it is non-resident students. So now we're going to call version number 3 over here. That's going to apply the discount rate of tuition. And then the discount rate is 0.5. And that one there, of course, will be 250, quite obviously, right? If you do the math. Okay, so that's about this particular example here. I want you to really think through about what's really happening over here. By allowing your command over here in the student management system as polymorphic, because you're being very generous about the type of the parameter here. So now because of call by value, so whenever you pass any argument value that is of static type, descendant class of the students, it will be allowed for compilation. And the consequence at the runtime is the runtime dynamic type for each of the member can be a descendant class of the static type, which is students. And then when you try to call the same query or routine on different elements of the array, in that case, because of its polymorphic nature, it might give you different behavior because of dynamic binding. Okay, think about this issue here before you move on to the next video.